Okay, my name is Kiichi Adachi. I'm President and CEO of Kringle Pharma. First of all, I want to thank organizers for this opportunity to present our clinical pipeline, Olmepermin alpha, which is a recombinant human HGF for the treatment of spinal cord injury. Kringle Pharma is a late clinical stage biopharmaceutical company located in Osaka, Japan. I think we are the only company attending this symposium from Japan. Actually, in Japan, the spinal cord injury become very serious because aging population is advancing, and now the SCI subject elderly population got SCI just by fall or drop. So it's getting very serious problem. So anyway, Kringle Pharma is now focused on the clinical development of recombinant human hepatocyte growth factor, HGF. HGF was originally discovered as a mitogenic factor for hepatocyte in 1980s. And since then, a basic research identified this HGF is a pleiotropic growth factor with multiple biological functions, as you see in this slide. It is not only mitogenic, but also angiogenic, morphogenic, motogenic, and anti-apoptotic. And there are four characteristic domains called Kringle structure is in alpha chain of HGF. Our company name Kringle Pharma came from these Kringle structures. As you see, HGF is very complex glycoprotein composed of 692 amino acids with 19 disulfide bonds inside one molecule. So it is very complex. One advantage of Kringle Pharma is that we already established GMP manufacturing of this complex protein, both drug substance and drug product. So the bottom panel is the final product, lyophilized product of the HGF protein. And once lyophilized, it is pretty stable. The shelf life is more than 5 years. So the first inspiration that HGF could be therapeutic agent for acute SCI came from the observation in rat SCI model. This slide summarizes endogenous regulation of HGF and c-Met receptor in spinal cord after SCI. Okay. So top left panel shows c-Met receptor messenger RNA expression, and right after the spinal cord injury, c-Met messenger RNA upregulated immediately and continue high expression during acute to subacute phase. On the contrary, ligand HGF messenger RNA as well as protein slowly increased its expression towards subacute phase. So it is quite obvious that in the acute phase, receptor c-Met expressed a lot, but ligand HGF is lacking to activate all the existing c-Met receptors. If this happened with the systemic organs like liver and kidney, then HGF was supplied from the intact distal organs by endocrine fashion. However, in the CNS, there is no such organ exist, and no HGF supply from systemic organs because of the blood-brain barrier. So the idea is if we supplementary treated HGF in the acute phase, we may have some therapeutic effects by activation of the c-Met receptors. The answer was yes. So the first therapeutic effect was demonstrated in classic rat SCI model, and then confirmed by marmoset SCI models. In both experiments, HGF was treated intrathecal infusion by osmotic mini pump implanted for 2 weeks in rat and 4 weeks in marmoset right after the injury. As you see, in the HGF treated group, functional recovery was significantly observed, both rat experiment and marmoset experiment. The reason why we choose intrathecal route for administration is to bypass blood-brain barrier, allowing for efficient dosing and minimizing systemic side effects. I just want to add one thing about therapeutic windows of HGF. In the rat model, we tested delayed administration of HGF, and we found out that if we start administration 4 days after SCI, that was still effective. However, if we start treatment 2 weeks or 8 weeks after SCI, we could not see clear therapeutic effects. So that means that the best timing of HGF treatment is the acute phase. So this slide just summarizes HGF mechanism of action in acute phase. So the problem in acute phase is the secondary damage. So once the secondary damage expanding, then in the chronic phase, it gets scarring and cavitation, leading to the decreased motor functions. If we treat HGF in the acute phase, again, HGF has multiple mode of action, and combining all the functions, HGF prevents expansion of the secondary damage in the acute phase, leading to the functional recovery afterwards. The main mode of action of HGF contribute the acute phase is neuroprotection, anti-inflammatory activity, angiogenesis, axonal regeneration and remyelination, enhancement of synaptic plasticity. Having these encouraging preclinical data, we move into the clinical stage in Japan. First clinical study we conducted in Japan was phase 1-2 placebo-controlled double-blind study. The target subject was cervical SCI with modified Frankel grade A, B1, or B2. Those subjects are very severe subjects with no motor function. We enrolled 45 subjects total, and 28 was HGF treatment group and 17 was placebo. Dosing was intrathecal bolus injection weekly 5 times in total, and the first injection was 72 hours after injury. Regarding safety, we did not see any safety issue observed, and there is no anti-HGF antibody generated. Regarding efficacy, we observed very encouraging data shown here. So left bottom panel shows the time course change in Asia total motor score, and throughout 6 months observation period, you can see higher motor score consistently in the HGF treatment group. We observed statistical significance on day 140. Right panel shows time course change in severity grading over time. And the colored part means the grade change from grade A to B or grade C. I want to draw your attention on the blue part, meaning 2 grade change from grade A to grade C1. So grade A is complete paralysis subject, and grade C1 recovering the lower limbs. As you see, 26% of the subject in HGF treatment group improved 2 grades, whereas only 6% in the placebo group. So this is the biggest difference we observed in the previous phase 1-2 study, although statistical significance was not achieved due to small sample size. After completion of this study, we obtained orphan drug designation in Japan and moved to the next phase 3 study. So before starting phase 3 study in Japan, we discussed with Japanese authority, PMDA, regarding the study design. And PMDA agreed that we conduct non-randomized single-arm phase 3 study using Japanese patient database as a baseline reference. So this slide summarizes AIS grade improvement in phase 3 study. And the center bar means the results from phase 3, and the left bar means that from the data from the database. Gray part means no improvement, so AIS-A at 6 months time point. The primary endpoint of this study was more than 2 grade change, which was represented as dark blue part. So in the phase 3, 12% subject improved more than 2 grade, whereas 8.6% in the database. The number was numerically increased, but it was not statistically significant due to small sample size. We observed big difference in the light blue part, which is the more than 1 grade change. In the phase 3, 56% subject improved more than 1 grade, whereas less than 20% in the database. And this is biggest difference, and it was statistically significant. When we compared our phase 3 data with US and EU databases, basically both US and EU databases, 70% cervical SCI grade A subject remains grade A, and 30% subject improved more than 1 grade. So again, our phase 3 data is superior to not just Japanese database, but also US and EU databases. So we clearly see the clinical significance of the HGF treatment in the acute phase for complete severe spinal cord injury subject here. Without any treatment, about 70% subject remains grade A, complete paralysis. If we treat HGF, we could rescue more than half of the subject from complete to incomplete. And this is very meaningful because once the subject goes to incomplete, then further functional recovery will be expected by rehabilitation or developing cell therapy. So having these encouraging data, we now discussed with Japanese authority PMDA regarding NDA filing in Japan. So in parallel with Japanese clinical activities, we are now seriously considering about clinical development in the United States in acute SCI with HGF monotherapy. We already completed a pre-IND meeting last November, and we are now preparing IND preparations. We already established very good KOL network, as you see in this slide, and having valuable advices from these KOLs, we are very confident to make clinical study design with high probability of success in the United States. So last part of my talk is future perspective of HGF treatment in SCI. SCI, spinal cord injury, is very intense disease, and subject condition changes moment to moment, acute to subacute, subacute to chronic. So everybody here knows that it is almost impossible to combat SCI completely just by single therapeutics or single cell or single device or rehabilitation alone. It's like putting pieces of puzzle together. It is important to combine right interventions at the right timing. We believe that we could maximize the value of HGF by the combination of cell therapy. Actually, we already conducted the joint research of Keio University in Japan, and we obtained very encouraging preclinical data regarding combination of HGF and iPS-derived neural stem progenitor cells. there are two experiments already conducted. The one is the HGF in the acute phase plus iPS cell therapy subacute phase. The other one is chronic phase. HGF combined with scaffold with iPS-derived stem cell therapy is effective. Those results are already published last year. Today, the time is limited, so I just want to touch one experiment. So this is a rat SCI model, and HGF was intrathecally infused right after the injury for 2 weeks. And on day 9, which is in the subacute phase, iPS-derived neural stem progenitor cells were transplanted. So then pre-treatment HGF changed microenvironment of the injured site more favorable to recover and regeneration. And the transplanted cell survived well, and it leading to the regeneration of neural fibers, as you see in the right part of the figures, leading to the functional recovery, synergistic functional recovery in terms of BBB score, as you see in the left bottom figures. So currently we are working on the HGF monotherapy in acute phase, and once we got a regulatory approval, then this kind of combination will be next step to try. So this is the last slide, summary of my talk. HGF or meperidine alpha is preclinically validated in animal model of SCI. And in the acute phase, HGF reduced secondary damage. And in the future, combination with cell therapy boosts functional recovery. We already conducted 2 clinical studies in Japan, phase 1/2 and phase 3. And the HGF treatment is highly safe. No anti-HGF antibody generated. And we observed strong efficacy signals. And now we are discussing PMDA regarding NDA filing in Japan. In the best scenario, we are going to file NDA by the end of this year. And since this product is already orphan drug designation, so in Japan, after 9 months after NDA filing, we will get regulatory approval. So that means the second half of 2025. And the last, we are now start clinical development in the United States. This is for acute SCI with HGF monotherapy. We are now preparing IND submission with variable advices from KOLs. And our plan is to be IND ready early next year. Thank you for your attention.